Now let's cover the Newton's third law of motion. Newton's third law of motion involves the concept of action and reaction forces. It says that for every force which acts on a body, there is always an equal and opposite force which acts on some other body. That means that if a body exerts a force on B, let's say we have two bodies, A and B. If there is a force acting on A by A on B, then body B exerts an equal and opposite force on A. Then B also exerts as a reaction force on A. So these two forces are equal but opposite in direction. Now let's apply the Newton's third law on different situations. In the first one, an object resting on a table. The object exerts a force equal to its weight on the surface. So the surface will react and with an amount of the weight of the object. This reaction force, we call it the normal force. So the normal force will be equal to the weight of the object. In the second one, I push the object with a value of F downwards. So I have also the weight. So the acting on the surface is the sum of these bodies. So the reaction force, the normal force, will be equal to the sum of these two forces. In the third one, I am pulling the object up with an amount of F. There's a force, the weight of the object. Think of that the F is smaller than the weight of the object. So the exerted net force will be equal to mg times F. So the reaction force will be equal to mg minus F. And in the third one, the weight of the object is here and it is not acting on the surface, so it will not create a reaction. What is acting on the surface is F, so the reaction force, the normal force here will be equal to just F. The skaters in the figure Arun has a mass of 60 kilogram and Yağmur has a mass of 45 kilogram. Compare the forces acting on them. As Arun push the Yağmur with a force of F, the Yağmur will react with an equal but opposite direction force F. So when I compare the forces acting on them, I can say that they are the same. When I compare the acceleration, they will gain as F is equal to mass times acceleration. They are under the influence of the same forces. So as mass is bigger, then the acceleration will be smaller. As mass is smaller, the acceleration will be bigger. So as the mass of Arun is bigger than the mass of Yağmur, so I can say that the acceleration of Arun is smaller than the acceleration of Yağmur. In this example, we have the given objects. They are pushed by a force of 20 Newton. First, we are going to find the acceleration. They have the same acceleration because they will move together. From F net is equal to m times a. The net force is 20 Newton. The total mass is 5 kilograms. So I have the acceleration equal to 4 meters per second square. Now the M1 will push the M2 with a force of, let's say, F, and M2 also push on M1 with an equal force F as a reaction force. Now I'm going to draw the free body diagram of 3 kilogram. The 3 kg is pushed by a force of F applied by M1. There are no other forces that keep the 3 kg in motion. So again, from F net is equal to M times A, F is equal to 3 times the acceleration 4, which is equal to 12 Newton. B and C will be the same because action force will be equal to the reaction force, which is equal to F 12 Newton.